You know, when you look up at the night sky, you're not just seeing a bunch of distant, twinkling lights. You're actually looking back in time, and you're looking at the source of everything that makes you, well, you. The story of our entire existence is literally written in the life and death of stars. So let's go on that journey together, from cosmic dust to their spectacular ends, and find out where we really come from.
You've probably heard that famous phrase before, right? We are made of star stuff. It sounds really poetic, almost like something out of a song. But what if I told you it's not poetry, it's biology, it's chemistry. It is a literal scientific fact. And to really get our heads around how that's possible, we need to follow the life of a star, from the moment it's born to its incredible, explosive death.
So, where does a star even begin? Well, it's not with a big bang. It's actually more like a whisper. Every single star, and that includes our very own sun, starts its life huddled inside these absolutely colossal, swirling clouds of gas and dust. We call them stellar nurseries.
Now, astronomers call these giant clouds nebulae, and you really can think of them as cosmic nurseries. Over millions and millions of years, gravity starts to do its thing, pulling all this gas and dust into denser and denser clumps. As a clump gets bigger, it starts to spin and heat up, forming what we call a protostar, basically a baby star. It's not shining just yet, but it's getting there, pulling in more and more material from a disk swirling around it, getting hotter and hotter until, bam! It hits a critical tipping.
And that tipping point, it happens at a mind-boggling 1 million degrees Celsius. This isn't just some random temperature. It is the ignition switch for the entire star. At this insane heat, the pressure in the core becomes so immense that it literally forces hydrogen atoms to slam together and fuse. This reaction unleashes a tremendous amount of energy, and in that very first flash of fusion, a true star is born.
Okay, so after that fiery birth, the star settles down into what you could call a long, stable adulthood. Astronomers have a name for it, the main sequence. And this is by far the longest phase of a star's life. I mean, our sun has been chilling in this phase for about 4.5 billion years, and it's got another 5 billion years or so to go.
The reason a star can be so stable for so long all comes down to this perfect cosmic balancing act. You've got gravity, which is relentlessly trying to crush the star inward, but at the same time, you have the immense energy from nuclear fusion in the core pushing outward with exactly the same amount of force. It's this perfect equilibrium, this cosmic tug of war that lets a star just shine steadily for billions and billions of years.
But, nothing lasts forever. Eventually, that long, stable adulthood has to come to an end. The fuel tank starts running low, and the star begins this dramatic, incredible transformation into its old age.
The beginning of the end is triggered by one single, simple fact. The star runs out of its main fuel source. The hydrogen in its core, the stuff it's been fusing for billions of years, is just gone. The cosmic engine starts to sputter and fail. So, without that outward push from hydrogen fusion, gravity suddenly wins that tug of war in the core. It starts crushing the core, making it contract and get even hotter. All this extra heat forces the star's outer layers to just balloon outwards, expanding to hundreds of times their original size. And as it expands, it cools, which makes it glow this sort of menacing red. This is a red giant. Or for the really massive stars, it's an even more colossal red supergiant.
And from this point on, the story splits. A star's path to the end can go one of two very different ways, and its entire fate is decided by just one thing: its mass. Basically, how much a star weighed at birth dictates exactly how it's going to die. You can see the two different paths laid out right here. On one side, you have the lower mass stars, like our sun. They have a relatively gentle end. They puff away their outer layers to form something beautiful called a planetary nebula, and they leave behind a tiny core called a white dwarf. But the high-mass stars, they go out with the biggest bang in the entire universe, a supernova. And what's left behind is either a neutron star or the most mysterious object of all, a black hole. Let's take a look at that first path. So that lower mass star will eventually puff its outer layers away into space, creating this absolutely beautiful, glowing structure called a planetary nebula. And all that's left behind is the star's dead core, a white dwarf. Now get this, it's only about the size of Earth, but it is so unbelievably dense that a single teaspoon of it would weigh several tons.
All right, now for path number 2. The death of a massive star is anything but gentle. Its core collapses in less than a second, triggering this absolutely cataclysmic explosion we call a supernova. For a little while, this one explosion can actually outshine its entire galaxy of billions of stars. It's an event of almost unimaginable violence and, believe it or not, creative power.
So what can get left behind after a supernova? Well, sometimes it's a neutron star. The core gets crushed so intensely by gravity that protons and electrons are literally forced together to become neutrons. What you end up with is an object only the size of a city, but it's so dense that a single teaspoon of it would weigh billions of tons here on Earth. Just try to wrap your head around that.
But if the original star was truly, truly massive, its core collapses beyond even the neutron star stage. It collapses down into a single point, creating a black hole, an object with a gravitational pull so powerful that once you cross its boundary, the point of no return called the event horizon, nothing can escape, not even light itself.
Okay, so we've got these two spectacular, wildly different endings, but this is where the whole story circles right back to us. Because in death, these stars give the universe the most profound gift. They leave behind an inheritance that makes pretty much everything else possible.
You see, the universe began with only the lightest elements, basically just hydrogen and helium. Every other element on the periodic table, the carbon in our cells, the oxygen we're breathing right now, the iron in our blood, even the gold in our jewelry, all of it was forged inside the intense heat and pressure of stars, and then scattered across the cosmos in those spectacular supernova explosions.
So, when we say we are star stuff, this is exactly what it means. The very atoms that make up our bodies, our planet, and everything we have ever known or touched were created in the heart of a star that lived and died billions of years ago. It's not poetry, it's our origin story. We are, quite literally, the children of the stars.